Hello, I am going to go through several of these problems today from homework number 4. And this is all on discrete distributions. All right, so using the multiplication rule, find the probability that the 3 guesses are wrong, the 4th is correct. Well, it looks like we have, on this version of the problem, I have 5 possible answers. So my chance of getting it correct is 1 in 5. So that means I have a 4/5 chance of getting it wrong. So this is a binomial with a probability of success being 1/5, just FYI for future reference. But we're just going to use the multiplication rule. 1/5 wrong, or 4/5 wrong for the first one, and 4/5 wrong for the second one, and 4/5 wrong for the third one, and 5/5 right. So we would just multiply that up. It would be 4 times 4, 64 over 625. Make that into decimal and put it there, right? And then it says, use the binomial distribution to find the probability of getting exact one correct answer when 4 guesses are made. All right, so I think I went through this question. I did. Sorry, it's been a long week, so you don't need to correct it, but I'll go through it anyway, and you can just forward ahead, and you'll see it again next week. So this is a binomial distribution where n is, how many questions? 1, 2, 3, 4. We're answering 4 questions, and we are probability of getting 1 correct, right? And probability of getting them wrong is 4/5. Right, so first of all, in the binomial distribution, we say, well, we have 4 questions, and we are choosing 1 to get right. So 4, choose 1. And then, right, the probability of getting 1 right is 1/5 to the first power, times the probability of getting 1 wrong, of getting 3 wrong, is 4/3. Right, you'll notice that this math right here matches that math right up there. Okay. Why do you have this? Because this didn't say what order you're getting them right. You could have guessed the first question right, and then wrong. You could have guessed the second question right, and then wrong. Or the third question, or the fourth question, right? So these 4 choose 1 denotes how many different ways I could do that, which is 4. All right, let's move on to the next one. So I went through that one anyway. All right, a local bakery has determined that the probability distribution for the number of cheesecakes that they sell on a given day is like here. They want to know first is what this is. Well, all of this has to add up to 1. So if I take 1 minus 0.11, minus 0.35, minus 0.21, minus 0.17, then that would give me whatever is left. And that's what goes there. And it says, what's the probability of selling at least 10 cheesecakes? At least 10. So 10 or more. That would be whatever number you got here, whatever this x was, plus the 10 or more. So whatever that x is, plus 0.21, plus 0.17. What's the probability of selling 5 or 15? Well, 5 is this, 15 is whatever this x is, so it's 0.35 plus whatever that x is. Notice if you get that x wrong, you're going to get all of these wrong, so go ahead and do this one first and hit enter, make sure you get a green check on it. Probability of selling 25 cheesecakes. 25 cheesecakes? There's no 25 cheesecakes. 0. Probability of selling at most 10 cheesecakes. Well, let's take a look at that. At most 10. At most 10 is less than 10, 10 or less. It would be this little area right here, right? Not that, just that. All right, so it's going to be 0.11, sorry about the background noise, 0.35 plus 0.21. Give the expected number of cheesecakes sold during a given day. And that expected number is the same as the mean. To find the mean, take the sum of the x's times the probabilities. So I would take 0 times 0.11 plus, so that's 0, 5 times 0.35 plus 10 times 0.21 plus 15 times whatever x was, whatever that number was, plus 20 times 0.17. Okay? That's that question. All right, now this is a long one. Hopefully you guys can see it all. All right, I'm going to tell you how to do this. I'm not actually going to do all the math because I don't have the technology here to do that. I am on a trip this weekend for my dad's 80th birthday. So, anyway, first we are going to take the number of days it takes to fix ICOS probability at their table. So, I would recommend that you do this in Excel or Minitab. And the way that you would do this is highlight this and copy it into one of those two spreadsheets. You could also use Google Sheets, all right? So select the random variable. First, the random variable is right here, the number of days to fix a pair of eyeglasses, right? That's the random variable. It's the number of days it takes to fix a pair of eyeglasses. If you were to make a corresponding histogram, what would this shape be? Would you notice that this has a lot of the probability at the 1, 2, 3, and by the time you get up to the 18, it's very, very small. So this shape would look like that, and that tail is to the right, so it is skewed right. Right? Find the mean number of days it takes to fix the defects. All right, so, and then you would write days. On Excel, this is what I would do, so I don't have to type all that into a calculator or something like that. I would, hang on, let's see if I can clear all of this. Okay, that was not what I wanted to do. All right, let's undo that. All right, there we go. That's what I wanted to do. All right, so on Excel, what I would do, or Sheets, or whatever you're using, and Minitab can do this too. In Minitab, you use the calculator function, and then you just like multiply. To find the mean number of days, I would take in, so you have this in column 1 and this in column 2. In column 3, I would say equals C, so this would be, let's do like Sheets notation. A, B, C, right? This is A, B, C in Sheets notation. So it looks like that, A, B, C. So this would be C1, A1 equals times B1. So you just go this times that. And you drag it down, so you have all of these multiplications. And then in D, you just write is the sum of C1 to however far this is. Well, C18, right? Because there's 18 of them. So that would give you, this is the mean. Right? And you would put that there. Okay? Moving up here. All right, now, as for the standard deviation, if you already have it in Sheets, I would do the same thing. So you have A, B, C, D, E. You can also do this in Minitab. You just use the calculate button and it will, and then store it in the calls. So here's your X's are in the A's, and your P of X's are in the B's. All right, and C's, I want you to write equals A1 times A1. So this becomes X squared, right? And then drag down, right? And then in D, I'm going to have you, this is going to equal C1 times B1. So this is X squared minus our X squared times P of X. Right? And in D, I want you to sum all of E, sum D1 to D18. Right? So I have the sum of this, and that's right here. So whatever number you get in D1, you're going to minus whatever number you got the mean squared. So take whatever number you got in part C, square it, and subtract. And that is your variance. That is your variance, right? But we're looking for the standard deviation, so now take the square root of your variance. So if you had saved this, like your mean, if you have your, say you have your mean right here from before in D2, you can do all of this math on your calculator, however you put your mean, by using this formula, equals square root of your sum, so let's say that's an E1, minus, and then wherever you stored your mean, let's say you put it in E3, and you square that, close parentheses. And that would be your standard deviation. So I'm basically doing this whole process by hand, and then because I don't want to type it into my calculator, because that's a lot of work. If you wanted to do it using your calculator, just type this in and that in, and I'll put the steps right here. Here's this. All right, so if you wanted to do your calculator, you could type all these numbers in, these 36 numbers. You would type this into list 1 and this into list 2. And then you would go to stat, calc, one variable stats, and then where it says X, you would write list 1 or data X, and then where it says frequency, you would write list 2, and then you would hit enter. And then the numbers that you were looking for on the list is X bar and sigma. So in your TI-83, we'll do the whole thing for you if you do that. All right, let's go back up and see where we were at with the last couple questions. So we find the probability it'll take at least 15 days to fix the defect. So 15 days, at least 15 days, is 15 days or more. Just add these guys up. All right, so there's that one. Let's take a look at the next one. All right, Kennedy has a basketball practice every 2 weeks. And 80% of the time she attends both practices, 15% she attends one practice, 5% of the time she does not attend neither. Complete the probability distribution. So I'm going to go from here. All right, 2, she does 80%, so 0.8. 1, she does 15%, 0.15, and 5%. And notice that adds up to 1. How many practices should we expect her to attend every week? So on average, she would go 2 times 0.8 plus 1 times 0.15 plus 0 times 0.05. 0. So this would be like, if I just multiply this out, 1.6 plus 0.15, this 0.175. And what is the standard deviation? I would take 2 squared times 0.18 plus 1 squared times 0.15 plus 0 squared times 0.05 minus 1.75 squared. This is the variance. So this is 4 times 0.8 is 3.2 plus 0.15 minus 1.75 squared. Sorry, my family is being so loud. 3537, 58, 0, 875. Oh, what are you doing? That would not be right. When you do that math, you square that. Sorry, I'm not going to take your time to watch me do long multiplication out. All right, and then you take the square root of that answer, and that goes there. And again, you could do this math on your TI-89, which is pretty easy because there's so few letters. Put that in L1, this in L2, go calc, stat calc, one variable stats, and then choose L1 for your first option. For your frequency, choose L2, and then hit enter. Okay. And next one. Natalie plays a game with the bias coin. Heads is With heads is 0.6 and 0.5. She plays each game tossing once. If she tosses heads, she gets paid $4. If she tosses tails, she wins. Okay, so this would be a -4 because she loses $4. Here she pays $10. Right? Probability of getting heads is 0.6. Probability of getting tails is 0.4. Right, well, is she going to make money in the long run? Well, let's find out. That's the average. So I go -4 times 0.6 plus 10 times 0.4. So that would be -2.4 plus 4. Oh, looks like she's going to come out ahead. That's nice. She's going to make, on average, $1.60. Right? And don't put the dollar sign. It's already there. All right, standard deviation. -4 squared, that's 16, times 0.6, plus 10 squared times 0.4, that's 100 times 0.4, 6 times 6 is 216, right? No, 96. So this is 9.6 plus 100 times 0.4 is 40. So minus 1.6 squared. So you do this math, that gives you the variance. Take the square root, get the thing. Again, you can do this in your calculator and put -4, 10 in L1, and then put 0.6, 0.4 in L2, and then go to stats, calculator, one variable statistics. You know, the faster you can get with your calculator, really, it does help you a lot. Kind of bypass the mundane calculations that you can sometimes get lost in the big picture. All right, moving along again, we have this one. All right, so we have this random table here. What's the probability of randomly selected person is measured exactly 6 times. Look here, put that number there. At least once is one or more. Take all of these and add them together. Or, easier, 1 minus 0.244 is that's the only one that's not there. What's the probability that a randomly selected person changes at most twice, so 2 or less times? Add these 3 together and put it there. What's the probability that change is made between 3 and 5 times? Add these together and put it there. Okay. And this guy right here. It's this local bakery one again. Very similar. Cheesecakes again. So we did this one already. I hope that answers all your questions. I'm going to post this. Please email if it doesn't. I am gone this weekend. I'm going to extend your deadline for your homework for just a day or so, and then so that I can get to everybody's questions. And then we will go from there. If there's anything you're missing, again, please let me know. Thank you for your patience.